Okay, so the final problem we have, this is actually 13.12, is now we're going to try and make a proton-antiproton pair using photons. We're going to shoot a photon at a proton. So we want to find the minimum energy, that E gamma. Find E gamma. So again, using the CM frame, I have the mass of a proton with the momentum of the proton colliding with a photon. Let's call it PCM gamma and E gamma CM. So using, let's use the momentum equation, so we're going to get gamma CM times the mass of the proton plus, I'm sorry, this is the energy of the proton. We're in the center of momentum frame. The energy of the proton plus the energy of the gamma CM, and this is going to be, you know, the after we just have one particle, 3 MP at rest. This is equal to 3 MP. And we also have a momentum equation, which is the mass of the proton times the gamma. Okay, this equation leads to MP gamma CM times 1 plus VCM equals 3 MP. So what I did was I substituted for E gamma CM. This is the same as the momentum of the proton, because in the center of mass frame, they're zero momentum frame. They're all the same. And so this is equal to gamma CM times MP times VCM. So I substituted this in this equation. That leads to that equation. And then I'm left with, after I cancel some things, gamma CM 1 plus VCM equals 3. This implies the square root of 1 plus VCM squared divided by 1 minus VCM squared, not in parentheses, equals 3. And that leads to 1 plus VCM, 1 minus VCM equals 9, which leads to VCM equals 4 over 5, and gamma CM equals 5 over 3. Now we have the numbers in the center of momentum frame. We need to get them in the lab frame. So we do a Lorentz transformation on the energy momentum 4 vector. This is equal to gamma CM times the energy minus 4/5. That's the gamma factor that we the velocity factor we calculated. And the momentum of the photon is going this way, so it's negative minus P CM gamma. And we established that the momentum of the photon is the same as the momentum of the proton, which is this gamma PCM. And so this is equal to, when we substitute all the numbers, this is going to end up equaling 4 MP. And that's equal to 3.75 GeV. And by comparison, this is the most efficient in terms of energy. The other ones were like over 5 and over 4,000. So if we want to make a proton-proton pair, a high energy gamma ray will be more efficient. And I got one problem left, and then we'll be finished with the relativity problems. Thank you.